Jai Hind everyone. Myself Pradeep Kumar Tripathi, Assistant Professor in Department of Information Technology. Today we have lecture series of Big Data, BCS 061, that is targeted to the student of third year IT and CSIT students. So now Big Data, in the previous lecture we can discuss about the how Big Data can use in industries and how Big Data can apply in that particular real scenario. Now we have discussed about the storage of big data that is used in Hadoop Distributed File System. We can store the data of big data in Hadoop Distributed File System. So this is the content of our PPT, that is the design of HDFS concepts, benefits and challenges, how the file size, block size and blocks are used in that particular HDFS and abstraction, data replications, and HDFS store and read and write files are there. So in this series we have discussed about the designing of HDFS and all these contents we have discussed. So why HDFS is used in particular in big data? When the data sets are increases and rapid growth of the data in the platforms like social media platform, Twitter, Instagram, Facebook and other platforms, there is huge amount of data generated in every moment of time that we can how we can store that particular data in a file system. So what type of file system can be used? There is a HDFS, Hadoop Distributed File System, that can be used for that purpose. So we can use that particular HDFS file system. So in the HDFS file system that manage the storage across the network of machines are called distributed file system. And the HDFS, which stands for the Hadoop Distributed File System, we can use. We can discuss the designing part of the HDFS. HDFS file system are designed for storing the very large amount of data that can be used in streaming data, access patterns, and running the clusters of commodity hardware we can use. What do you mean by the very large amount of data or very large file? That can be hundreds of megabytes or gigabytes and terabytes to petabytes, that call the very large file. Suppose we have a text file of KB, MB and GB, that is not a large file. The large file means that is depends on petabytes to terabytes data that can be used in the HDFS. And what do you mean by the streaming data access? Streaming means live real time of data that can be used in live streaming. So HDFS is built for that particular data that is range from petabyte to terabytes. Either it is streaming data that can be used. So in the very large amount of data and streaming data access that can be used in the HDFS designing part. In commodity hardware, there are Apple computer running on the Mac OS. Hadoop does not require the expensive and highly reliable hardware to run on it. So it needs to the cluster of commodity hardware that can be available for the multiple vendors, and it gives the node failure across the cluster is high, at least the large cluster. So HDFS is designed to carry without noticeable interruptions of the user in such failure. Suppose we have a large number of nodes. Suppose we have a node 1, 2, 3. These are the clusters of the node. Suppose one node is failed, then the other node will carry that particular part. If this node is failed, then other node is carry that particular part. So it is designing like that no failure occurs in that particular time. Why we use the HDFS not good fit today? Because low latency data access, lots of small files, multiple writers, attribute file modifications are there. Low latency data access means the ability of the computer system or network to provide response with a minimum delay. What do you mean minimum delay? Delay means that is related to the time response. Suppose we have a process some request I1 that takes 5 minutes in HDFS part. Suppose we have stored the data in I2 in 2 minutes directly in the Excel file. So 2 minutes is less time and 5 minutes is more time. So low data latency data access means response time is maximum. So we cannot fit that particular of HDFS in that particular scenario. We need some millisecond range of file system. So HDFS is not suitable for low latency data access. Similarly, lots of small files, that means if the file size is KB or GB or MB, that cannot be suitable for the HDFS. HDFS is suitable for the terabytes to petabytes. That a large amount of data are there, a huge amount of data that we can use in that particular HDFS. Suppose we have some writers can use that single file. Suppose we have a file of one file, that name is A, that can be user 1, user 2 and user 3. Suppose we want to access that particular file and we want to modify that particular file at same time. In that particular scenario, we cannot use HDFS because HDFS not give the facility to multiple writer to modify that particular single file. So in this particular scenario, we cannot use the HDFS, low latency data access, lots of small file or multiple writers. So we can use HDFS in only the case that that can be exist in large amount of data, like social media platforms like Twitter, Facebook, Instagram and other platforms where we can generate the huge amount of data. Then we can use the HDFS. What is the features of the HDFS? The features of the HDFS is, one is distributed storage and processing. Another is command line interface for the interactions of the HDFS, and the built name server is NameNode and DataNode. There are the two type of node that we can use in HDFS. Later on we can discuss about the NameNode and DataNode, how it can be collaborate all these things in clusters of that HDFS. And streaming access of the file system and HDFS provide the file permission and authentication. These are the features of the HDFS. One by one we can discuss about the features of the HDFS. Here is the architecture of HDFS, and that is a block diagram of HDFS. One is secondary node node and datanode. There are the two types of node that can be divided in the HDFS. One is datanode and other is NameNode. NameNode is a work as a master node that can be handle all these things of the HDFS. And NameNode can provide all the signal related to the data node. In the data node, we can store the particular data blocks. We can, suppose we have a file of terabytes and petabytes, then we can divide into the blocks. We can divide that particular file into the block B1, B2, B3 up to Bn. We can divide that particular file into the block, and blocks are stored in the data nodes. And that data node can be controlled by the namespace that is called NameNode. NameNode has two parts. One is namespace, another is block management. That can be block mapping are there, how the blocks are connected, how we can use that particular block in the data node with the help of NameNode. In this HDFS architecture is basically divided into only the two parts. One is NameNode, another is DataNode. In that particular architecture, we can use the HDFS, and how the HDFS work. NameNode can pass the instruction to the DataNode, and DataNode can give the permission to the access that particular data files that is stored in a blocks. How the one file can be stored in HDFS architecture, and how the file can be accessed from this architecture. Suppose file 1, file 2, and the client can be give the request to the server, and the server gives to the NameNode and name node decided the mapping of file 1 to 1, 2, 3, 4. That is the data blocks of the 1, 2, 3, 4, and the file 2 are stored in the 7, 8 and 9 blocks. And these are the nodes that can be replicated. Suppose we have seen the 1, 2 times 1, and 3 is almost 2 times, and 4 is also 2 times, 9 is also 2 times. So these are the blocks that can be replicated. It is the feature of HDFS, because if the replication is done, suppose one node is failed at that particular moment of time, either it is hardware failure, either it is software failure. At that particular time, we can recover our data from the other node, because there are the same type of data we can store from more than one places. That is the USP of the HDFS, because if one node is failed, then we can access that particular data from the other node. That can be decided by the name node. Name node is a basically master node, or it is called master and slave relationship. One is master, another is slave. So master node is means name node, and slave node means data node. If one data node can be failed, then master node can decide how the data can be recovered from the other node, because the mapping part is done by the name node. Name node decides how the blocks are replicated and how much time that block can be replicated. So name node is basically the control part of HDFS architecture, and it can be decided to the how the data can be distributed in blocks, and how much times blocks can be replicated, and what are the blocks and what are the mapping of that particular block in that particular node. So overall architecture can be here around the name node and data node. There are two basic type of node that exist in particular HDFS architecture. Suppose one client that access that particular files, so it can be requested to the name node, and name node decided how the data are stored in the blocks. They can 1, 3, 4. Suppose node 1 contains this, node 1, 2 contains this, node 3 contains this, and files are mapping to the data blocks. So name node decided how the data can be accessed. Name node check the authenticity of the client. If client is authentic, then it gives the permission to the client. The client can access that particular data node. So it is the HDFS architecture, and in HDFS architecture, master slave architectures are there. Master node can access data nodes, and they can decide to the replication factor how much times of the data can be replicated. So in HDFS name node, we can elaborate the HDFS name node and data nodes in details. So what is the HDFS name node? HDFS name node means the file system namespaces provide the two types of images. One is FS image and edit blocks. There are the two types of content that name node can exist. Name node contains the FS image, that is stands for the file system images, that can be complete namespace of the Hadoop file system from the name node creation. And the edit logs, what the edit log contains? It contains all the recent changes that can be performed to the file system namespace, because in this there are the two informations are there in for the name node. One is file system image, another is edit logs. Edit log contains all the changes that can be exist in the particular name node. So in name node, only the two types of workings are there. Suppose one is primary name node, another is secondary name node. Why we can use secondary name node? Because the replication quality of HDFS, we can use secondary name node. For primary name node, send the request to the secondary name node, because all the data, same type of data is replicated in secondary name node. If the primary name node is failed, then we can generate the data from the secondary name node. One is edit the blocks of primary name node. Then this copy is stored in the edit, and this copy is stored in the FS image, and all the FS image is merged with this point third. Then this can be replicated to the primary name node, and after that the primary node. But this is the final changes of name node. The name node contains only the two parts finally, FS image and edit blocks, because these two type of information is associated with the name node. So in the name node we can use that particular scenario. We can use name node and data node, and how the name node and data node can be connected to this. What are the functions of HDFS name node? That is the for the execution purpose. It executes the file system namespaces like opening, rename, closing, and file directories. And name node maintain the data nodes. It mapping of the blocks. Each change is made to the file system, location of that particular file, replication factor, how the replicated the blocks. Suppose we have one file, and that particular file is replicated 2 times. Another file we have replicated 3 times. How it can be decided? It can be decided by the replication factor. That can be decided by the name node. It is the main function of the name node, because how much times data can be replicated to the one place to another place. So it is the main functions of name node we can use in that particular scenario. If the data node can fail, the name node can choose new data set from the new replicas. So this is the function of HDFS name node, and that particular function of the name node can be exist in particular scenario. So this is the function of HDFS name node, and how the name node can be used in scenario of HDFS. So we can use that particular name node in particular scenario, and this type of name node we can use in HDFS. So we can use the HDFS name node, and what are the HDFS data node? In data node we can responsible for serving the client and read and write operations, creation, replication, deletion, and report to the name node. It is the basically ground level reality of the HDFS, because the ground level reality data can be stored in a data node. Data node can be blocks, contain the blocks of the files. In previous diagram we can see how the data nodes can be stored. This is called the data node 1, this is called data node 2, this is called data node 3. These data nodes can be ported to the name node. So here is the architecture of name node and data node, and data node and name nodes are connected to each other. So this is the overall architecture of HDFS and designing part of the HDFS. How we can store our files into HDFS. So in this lecture series we can conclude our HDFS designing part. In next lecture we can use the more elaboration of HDFS and how HDFS can be used in recent scenario, and what are the possibilities and future aspects of the HDFS we can use in that particular scenario. So it is all about the HDFS lecture. So in next series we can use particular future scopes of the HDFS.